Hello, algebra students. We are going to spend another couple of days on something that relates to what we were doing with writing linear equations. We're going to be working with arithmetic sequences. I know it looks like the word arithmetic. You say it arithmetic because it's describing the kind of sequence. And we're going to be looking for patterns in this kind of a sequence. In an arithmetic sequence, we have a common difference, it's called. It's what we're adding, or it might look like subtracting to get from one term to the next one. Remember, the terms are just the numbers in the sequence. So this is the first term, this is the second term, the third term, the fourth term. That dot, dot, dot means that it's going to keep on going. Because we're adding 5 every single time, that is our common difference. We will also have, when we're writing an arithmetic sequence, this is going to be an important number because it's the first term in the sequence. Those are the two things that we're going to need. The first term in the sequence, and then whatever the common difference is. So in this problem, if I just have to find the next 3 terms, you can see this pattern, and it looks like the numbers are, some people think that they're increasing because they're just looking at like 7, 14, 21, 28. They're negative numbers, they're actually decreasing. So they're getting smaller. The table that I'm going to show you, you certainly could do this, but you really don't need to show as much work as what I'm going to show you underneath here. You could just say, well, the next number, when I would add another -7 or subtract 7 from this, would be -35. And then I would do that again and I'd have -42. And then one more time and I'd have -49. So the work that I have here for you that you can see is, here is just kind of analyzing the information that we know. We're adding a -7 to every single term, and that's how we're getting to the next term in the sequence. And then they're saying, okay, let's just continue that pattern. Okay, you can certainly fill in a table like this if you want to, but you really don't need the table as far as I'm concerned. So in these problems, just continuing on in the pattern of the sequence. The first one is, these numbers are increasing, right? And they're increasing by 12. So if I just add 12 to the next one, I would get 36, and then I would get 48, and then I would get 60. In number 2, yeah, they're decimals, but that's okay. What's happening here every time, I am adding 0.4 to get to the next term. So my next one would be 1.8, and then I would add 0.4 again, and I would have 2.2, and then it's going to get kind of squished here, so 2.6, right? Finding the next 3 in a pattern, not that big a deal. And I know that some people are going to look at this one with the fractions and freak out a little bit. This is decreasing, so it's got a negative common difference. And if you observe what's happening here, especially if we would change this one to say 3 2/4, you can see that it's really just decreasing by 1/4 each time. So the next number would be just 3, then it would be 2 3/4, and then it would be 2 2/4, or 2.5. This is the real work of what we're going to be doing. We're going to do a little bit of this today, but this is mostly what we're going to be doing tomorrow in the next lesson. This is called the explicit formula, or the explicit form of this arithmetic sequence. This is what you need. I know that that looks a little bit intimidating with those subscripts. We've seen subscripts before in slope formula and in point slope form. But it's about which term we're talking about. So you can see, it says right here, a sub 1 is the first term. So the first term in a sequence, we're going to put that number right here. The D is the common difference. We're figuring out what we're adding every single time. The N that's in here, this N and this N, those are just going to, for now, just stay as N's. We're going to be saying, if we wanted to find, let's say, the 10th term in a sequence, then it would be a sub 10, and this would be 10 minus 1 in parentheses. But when we're just substituting in the information that we know, we just put in those two things, the first term and the common difference, okay? So if I have this arithmetic sequence, 14, 11, 8, 5, the first term is, again, just the first number in the sequence. That's 14, okay? So that's going to be the first term. The common difference is what's happening every time. This is decreasing by 3. So we're adding on -3 every single time. So our common difference is just going to be -3. I'm going to put those two numbers into the right spots, right? The a sub 1, we just put in that 14. The common difference, we put it in -3. Notice that we put the -3 in parentheses because we're going to be multiplying there. We don't want it to look like we're subtracting 3. Now, all we really have to do to simplify this, we're just going to kind of clean this up, right? We wouldn't leave all of that mess in any math problem for algebra. We're going to take this -3 and we're going to distribute. Okay, so I need a little bit of space here. So I would still have 14 plus -3 times n is going to be -3n. And then -3 times -1 is +3. And then again, I would say that 14 and the 3, we're just going to combine those, right? Those two things go together. Here's our equation. We put the -3n first. 14 plus 3 is 17. That's my arithmetic sequence. That's the explicit form of the arithmetic sequence. If I want to find the 50th term, I don't want to take that sequence from the top of the screen and write out 50 numbers. That's ridiculous. There's a much easier way to do this. The 50th term just means that I want to find when n is 50. So I'm looking at this n right here. I'll kind of squished it a little bit, and that n right there. So we're going to substitute in the stuff that we know. A sub 50 would be -3 times 50 plus 17. And then we would just crunch those numbers. -3 times 50 is a -150, plus 17 is going to be a -133. Without having to make a list 50 numbers long, we can get what that value would be. So for this one, my first term, this is what I want you to do on every one of these. My first term is 4. My common difference, what's adding on each one of these? 1. So the explicit formula is a sub n equals a sub 1 plus n minus 1 times d. The a sub 1 is 4. N minus 1 stays there. The d is 1. All right, well, distributing this 1 isn't going to change anything, right? I would just have 4 plus 1n, and then 1 times -1 is minus 1. So I have for my explicit formula n, or 1n, plus 3. If I want to find the 25th term in this sequence, I would say, all right, my 25th term in the sequence is going to be 25. That's what the n is, plus 3. It's 28. Okay. For the second problem, my first term is 8. So a sub 1 equals 8. My common difference, each time I'm adding 8 here. So the d is also 8. So I'm going to use this form right here. A sub n. Instead of a sub 1, I'm going to put that 8 in there. And then n minus 1 times my common difference. So we distribute and then combine like terms. Very similar to a lot of the other work that we've been doing. It's 2 steps for this. This is not that difficult. 8 plus 8n minus 8. All right, well, when I add this 8 and that -8, those are going to cancel. So I just have that a sub n equals 8n. So if I wanted to find the 25th term, I would just say 8 times 25. Well, if you had 8 quarters, that would be 200 cents. It's going to be, my 25th term is just 200. You're not going to have any problems where you have to graph, but I want you to see how this stuff that we're doing relates back to slope-intercept form. So we've got a carnival charges $2 for each game after you pay a $5 entry fee. So for the total cost that we've got here, one game doesn't cost $7, but it costs $5 to get in, plus the $2 for the game is where we got that. So we're adding the $5 on to that cost for each one of them. So to write this as an arithmetic sequence, I would start with, sorry, my first term, my ace of 1, playing one game, is 7. So this is ace of 1. And my common difference is, oh, I almost put the plus sign too early. The common difference is 2 because I'm adding 2 every single time, right? We add 2. So to write my equation, ace of n is going to be the first term, n minus 1 times my common difference. And then we just clean this up. 2n minus 2. And then we would combine those like terms. So ace of n equals 2n plus 5. And that equation should make sense based on other stuff that we know already. We did story problems like this. The $2 is the slope because it's increasing by $2 for each game. And the $5 was the y-intercept because that's what you had to pay to start. So if you can look at this, and I know that this first part you probably don't recognize because we haven't talked about function notation, but this is just saying y equals 2n or 2x plus 5. If you change it to an x to look like slope-intercept form. If we would graph this line would continue right here. The y-intercept is 5. It's increasing by $2 each time. So again, you're not graphing today, but I wanted you to see that relationship between this arithmetic sequence and slope-intercept form. The worksheet that you have today, some of the problems you're asked to figure out if it's an arithmetic sequence, and if it is, what the common difference is. And then you also have to do some problems where you're finding what's the first term, what's the second, third, fourth, fifth, or some other number that they're going to ask you to do. And then there's 2 problems at the end where you have to come up with the arithmetic sequence. If you have any questions about that, you can absolutely check the key in Schoology and then make sure you take the formative when you're done. Good luck.